Hi, everybody. My name is Mayukha. I'm a senior software engineer at Ripple, and I'm here to talk to you about XRPL plugins. This will be an interactive workshop, so I hope you're all ready to participate. Don't worry, you do not have to be a dev to be able to contribute. So first off, let's talk about what exactly a plugin is. It's basically a piece of code that you can write in your programming language of choice that allows you to essentially prototype or write an XRPL feature amendment. So the current languages that are supported are C++ and Python, but theoretically, any language can be supported in the future. What we'll be talking about today is first we'll go over how the XRPL processes transactions, so you have a little bit of background. Then we'll talk about the different parts of a plugin, and then we'll get into designing your very own amendment and diving into the code for that amendment. I've got an example amendment that I think you guys will all have a lot of fun with. So first off, what is a transaction, really? You may be familiar with transactions on the XRPL, but what really is it what role does it play in the system that we call the XRP Ledger? So a transaction, it's the only way that you can modify XRP Ledger state. So you can do so by creating, modifying, or deleting ledger objects. And this commits data to the ledger that users or servers have access to. You can think of it as sort of analogous to a method in a smart contract for those of you that are more familiar with smart contracts. And transactions have to be submitted by an account. There's a few exceptions, but those are called pseudo-transactions, so they're not really covered here. Next, what is a ledger object? So a ledger object is how the XRPL stores our ledger data. And it's sort of analogous to a collection of state variables in a smart contract. And other than a few exceptions, it must be owned by an account. And we've got an example of what that looks like over here. Now, how does the XRPL process transactions? When you submit a transaction to the XRPL, what that is under the hood is a submit request. And then that's sent to RippleD, the code that runs the XRP Ledger. And what it does is it first checks the format of your transaction, make sure that you have all the required fields, and you don't have any fields that it doesn't know anything about, or anything like that. And then it passes it to the correct transaction handler. This is often called a transactor in RippleD. So what are the different parts of a plugin? First off, we've got the transactors that we just discussed, your transaction processing handlers. You've got ledger objects. What new ledger objects do you want to be creating as a part of your amendment? S fields are serialized fields or parameters. They're the fields in your transaction. You've got serialized types, which are the different types that a field can be, such as an account or a uint 16 or something like that. Then you have the amendment itself. This is just the gate that you open and close that is done for activation purposes. It's not the code within the amendment, just the gate itself. Then you've got transaction result codes, which are the various result codes that you can return. You can create new ones if you'd like. There's invariant checks, which are sort of one of the magic pieces of the XRP Ledger. It makes sure that nothing happens on accident that you don't want to happen. For example, creating new XRP out of thin air if there's a bug in your code. You can add an invariant check just to be sure. And then there's inner object formats, which are for more complex fields. When you have an object within an object in JavaScript terms or something like that. Now, if you didn't really follow most of that, that's fine, because we're only going to be talking about transactors and ledger objects today. So, yeah, hopefully you understood that part. Now, the architecture of a plugin is fairly straightforward. So we have a running instance of RippleD. So this is the server that you're connected to. There's a library that RippleD depends on called XRPL Plugin. It contains a lot of different code that is required, all the different objects that you're going to be working with, all the different pieces of code that you're going to be working with. That's all in this XRPL Plugin library. And so if you want to add support for plugins in a new language, such as I did for Python, you can basically implement XRPL Plugin or write a wrapper in your target language. And that wrapper library is then what you will use in your plugin itself. So And then that library is then called by RippleD, and it pulls all the data that it needs as it needs it, and it runs the code in the plugin as it needs to. Everyone following so far? So now it's time for our example amendment, and time for you to design your own amendment. So our example amendment here will be NFT auctions. Yeah. So first, a few notes on how you design an amendment. An amendment has transactions and ledger objects. Transactions are the methods or the operations of your feature, and ledger objects are the state variables of your feature. So let's take NFTs as an example. NFTs, the operations you can do are minting and burning, and you can create, cancel, and accept offers as well. So those are your 5 transactions for NFTs. And then there are 2 ledger objects. You've got your NFT pages, which collect up to 32 NFTs, and you have your NFT offers. Everyone following so far? Next question is you got to participate, so I hope you're following. So what ledger object or objects do you think that we need for NFT auctions? And if you need a refresher, here's what a ledger object is again. Please raise your hands if you have any ideas. What information do we need to be storing on Ledger? Hand in the back.
Create auction.
I'm asking for ledger objects here.
Objects of the auction.
The auction, do you have a hand? Current highest bid. Yeah, so you can store this as, I believe that's Dennis back there, said you can create an auction object. And so what are the fields that we're going to need? The current highest bid would be one of them. Any other fields? What other ledger data do you want to be able to store on Ledger about this auction? Expiration? Sorry, can you guys raise your hands? It's kind of hard to hear when multiple people are shouting. Yeah? Sorry? The owner, yes.
The sequence of the bids?
The sequence of the bids? Sure. For simplicity, we can just store the highest bid, just so we don't have to store too much data on Ledger. You can always look at Ledger history for past bids. We have another hand over here.
What is being auctioned?
What is being auctioned? So the NFT itself. Yeah. So I think that covers most of it. So we have the fields that I came up with are the owner, the NFT that you're auctioning, what's the minimum bid that you want to accept, who's the current highest bid and highest bidder, and what's the expiration. So you guys got pretty much all of that. Nice job. Now, what are the transactions that we need? What are the operations that we want to be able to do here? Create auction. Bid. I assume you mean bid on the auction. There's no selling in an auction. What? Yes. Complete the auction, and there's maybe one more operation.
I was going to say win the auction.
That's probably the same as complete. Winning the auction is going to be the same as completing the auction. Yes. Cancel the auction. Yes. So there are your 4 operations here: create, bid, finish, and cancel. Those are your 4 transactions that we're going to be working with here. So now let's dive into the code itself. We'll go through the auction create transaction, and then we'll work through the auction bid transaction together. If anyone has their laptops and wants to follow along with the code, I have a Docker link right here that you can pull down and be able to run and read the code yourself. But if you don't have your laptops or you're not a dev, don't worry too much about it. We'll stay pretty high level. So first off, what are your core transactor functions? How is the XRPL processing your transaction? So there's 3 main functions here. You've got pre-flight, pre-claim, and do apply. So pre-flight is what is literally everything you can check about the validity of the transaction without needing to check anything about the current ledger state. So just from the data that is in the transaction, what can you check? So for example, a payment shouldn't have a negative amount. That doesn't make any sense. That sort of thing. I don't need any access to what's currently on the ledger in order to be checked that. And the reason that we want to check literally everything is because this function is run before the transaction is sent to any other nodes. So it really saves a lot of performance and efficiency if you catch as many errors as you can in this particular function. Then we've got pre-claim, which is What is everything that you can check about the validity of the transaction when you have read-only access to the ledger state? So now you have access to ledger data. You can check things that involve looking at the ledger. For example, does this account that I'm signing a transaction for exist? Yeah. And then you've got do apply, which you can do a few additional checks if you'd like, and then you actually try to apply the transaction. This is where you actually, in a payment, for example, you send the money from your account to the other account. So first off, let's start with our parameters for auction create. We need an account. We need to be creating this transaction from an account. We need the NFT. What are we auctioning off? We have the expiration, and we have the minimum bid. The minimum bid is optional. If it's not specified, it's basically just 0. Yeah, so this is what that transaction might look like. That expiration is, I believe, set for the end of the year, just for funsies. And so this is what the code might look like. I'm not sure if it's quite readable from the back, but hopefully it is. If not, feel free to check out the code later. So first off, we're passed in this object that's called CTX, short for context, which is basically all of the information that you're given in order to process this transaction. So that includes the transaction, it includes what amendments are enabled and all of that sort of thing. So first off, we want to make sure our amendment is enabled, our NFT auction amendment. If it's not enabled, then we want to throw an error because we don't want transactions to be submitting before an amendment is enabled. Then we want to make sure that there's no flags. We didn't discuss any flags to be putting on this amendment, so on this transaction, so we want to make sure that someone didn't accidentally include some flags. That probably means something's wrong. Then we've got some basic checks, like ensuring that the sequence number is correct, that the fee is a valid value, all of those sorts of things. That's done in this helper function called preflight1. And then we want to make sure that the minimum bid, if it's included, is a valid value. So we want to make sure that, for simplicity's sake, we're only sticking to XRP bids. So we want to make sure that it's going to be an XRP amount, and we want to make sure that it's not a negative value. And if it's one of those things, then we want to return another error. And if all that works, then we can declare it a success for now. Following so far? Okay. Now we've got pre-claim. We get another context. This one's a little different because it gives us some access to ledger state, which we can access with this ctx.view field. And what we're doing here is we just want to make sure that this NFT exists and is owned by the account that's submitting this transaction. And we want to make sure that this NFT is transferable, because if it's not transferable, then we shouldn't be able to transfer it to someone else, which we have to do for an auction. That's basically all the checks that we do there. Next, we've got do apply. So we're going to be doing a bunch more checks here. And so first off, we want to get our account and the account information that is on Ledger. And SLE is short for ST Ledger entry, and it's basically, what is the Ledger object data that is stored on Ledger. So we get the account Ledger data. If the account doesn't exist, we already checked that the account doesn't exist previously, that the account exists previously. So if it doesn't exist here, it's just a sanity check, but it means something really went wrong. So we're throwing an internal error there. And then we want to make sure that this account has enough object reserve to be creating this new object. If it doesn't, then we want to be throwing an insufficient reserve error. And then we get the NFT. And previously, we already checked that the NFT exists in pre-claim. So if it doesn't exist, then clearly something went wrong again. So we want to be throwing another internal error. And then we want to remove the NFT from the account's owner directory, because we want to stick it into this object, into this account object, so that they can't, sell it to someone else while the auction's going on. You're essentially putting this NFT in a bit of an escrow while the auction's going on. You can think about it that way. And next, the rest of the function, we create the auction now with this function called make SLE, which makes a new ledger object. And then we populate it with all of its fields, the account, the NFT, the minimum bid, and the expiration. And then we do a couple steps to essentially insert this object into the ledger. So we need to insert it into the ledger as an object, and then insert it into the accounts set of objects, which is called the accounts owner directory. And then we need to add one to the accounts owner count, which is keeping track of how many objects that account owns. If any of that fails, then we throw an error along the way. So let's see a demo of how that code runs now. Can we switch to the laptop? Excellent. Okay, so on your right here, we've got some code that I'm running. So I'm going to run the same Docker container that I gave to you. And I have this helper function that I call run.sh that I'm going to run, which what this is going to do is it's going to mint an NFT and create an auction. This will take a couple seconds as this runs. And on the left here, I have an Explorer that is connected to the local version of RippleD that I'm running. So we can then look at the transactions that are running. So the transaction succeeded, it looks like, but let's take a look at this Explorer. And as you can see, there's this auction create transaction in Ledger 5, which matches the ledger index here in the metadata. And if we take a look at the data here, you can see that the expiration is this time that is way in the future, and this NFT ID. And if we take a look at the metadata here, I can zoom in a little bit here. If we take a look at the metadata, then we can see that an auction ledger entry was created, and it's got the account, the expiration, and our NFT right here. Okay, can we go back to the slides now? So now it's your turn to help me go through the auction bid transaction. So first off, what are the parameters that we're going to need in this transaction? What information do we need to place a bid? In the front here?
How much you want to bid?
How much you want to bid, exactly. Over there?
Current bid?
The current bid you do not need to put in the transaction because the ledger already knows that data. So you don't need to include that extra. Like what information, like you want to place a bid, what information? You need the amount you're going to bid. What other information might you need? I see a hand in the back. The auction ID.
There's a mic.
Oh, there's a mic.
If you give me a couple of seconds, I can reach you with the mic when you have a question.
I'm sorry. I'll let you do that.
Wallet address creating or
yeah, the auction. The auction. You could do the auction creating. You also need the account that you're submitting this bid from. All right. I think we've got it all. So we've got the account, the NFT ID, and the bid amount. So someone said the auction ID earlier. That would be one way to do it, but I simplified that a little bit by ensuring that the auction ID is created just from the NFT ID. If I go back a few slides, where is it? So the auction keylet, the keylet is basically constructing an object ID from the parts that make it up. So, for example, an NFT ID has like the flags and the issuer sort of encoded in it. This is a different way of encoding data, but this is encoding just the NFT ID. So I can essentially regenerate the auction ID just by encoding the NFT ID in using this method, and so it's easier, it's a little more user-friendly to just use the NFT ID instead of the auction ID directly. So, all right, now for pre-flight. What can we check in pre-flight? What is literally everything that we can check of the validity of the transaction just by looking at the transaction, no access to ledger state?
checking the bid is valid?
Checking that the bid is valid, good.
Expiration date.
The expiration date, yes, we can't check that in pre-flight because we don't have the expiration info just from the transaction. That's stored on Ledger, so we have to do that in one of the later steps. But remember that for later. Anyone else?
What about time?
That was you asked about time. That's what the gentleman in the front was talking about, expiration.
Is this where you check the, whether or not the amendment's enabled?
Exactly. You do check whether or not the amendment's enabled. Is a hand in the back, or was that just you adjusting your hair? All right. So you check whether the amendment's enabled. You check that the transaction has no flags. I'm sure if you guys wanted to, you could come up with ways in which you could use transaction flags, but we didn't talk about that, so therefore there are no transaction flags. You also do your basic pre-flight 1 checks, like making sure the sequence number is a valid number and all of those types of things. And as you said, ensuring that the bid is a valid value, making sure that it's XRP and greater than 0. And then we check the signature on the transaction. All right, now what can we check with read-only access to the ledger state? So you could check the expiration here to ensure that the auction isn't expired. I chose to do it in do apply. It's a little fuzzy which checks you do where, to be honest. It depends on the developer and their desires. Usually what I like to do is pre-claim is the ones that are sort of always going to be true or less likely to change. But yeah, so other side note aside, other pre-claim checks people might have?
But you did the balance in the pre-claim, right?
I did
that could change.
The balance of the account?
Yeah.
So I did that in do apply as well, but you could do that in pre-claim theoretically.
The NFT ID or the auction ID?
What about
valid?
it? Exactly. Whether there's an NFT whether there's an auction that exists for that NFT. Anyone else? One more here and
Whether the
here.
owner exists.
Whether the owner exists, yes.
Would we check if the amount you bid is greater than the current bid?
You could do that, yeah. Okay, so what I did here was I checked that the auction exists. I made sure that the bidder isn't the same as the seller. We really want people to be able to bid on the auctions that they create. And I checked that the bid is at least the minimum bid. Some of the other checks mentioned here, I didn't do apply. So that would be, which, we may as well skip to that slide now. So, checking the expiration, checking the balance, ensuring that it's the highest bid. Anyone else have any ideas on what we want to be doing here? This includes both additional checks that we haven't done yet and also what operations we want to do. In the back? Sorry? Add the bid to the ledger. Good. Sorry, we gotta.
Of the bid.
Can you repeat that?
Of the expiration of the bid.
The bid doesn't have an expiration. The auction has an expiration. Yes, so you do need to check the expiration that the auction isn't expired. Good.
You're going to increment the account of the NFT bidder.
You mean what? I don't quite follow.
You have to increment the number of NFTs the bidder has.
So we're only bidding here. We haven't won the auction yet.
Okay, I thought you were applying.
No, this is just placing the bid. So this is placing the bid. The auction hasn't ended yet.
What about checking the balance to make sure they can pay for it?
Yeah, checking the balance, exactly. Okay, so I feel like we've covered enough of the checks. So, ensuring the bidder has enough money, checking the balance, ensuring the auction isn't over, ensuring that the bid is the highest bid. So what are the operations? What changes do we want to make to what's stored on Ledger now? Sorry? Can we bring the mic over?
Concurrent bids.
So in
Many
this,
people have exactly the same bid.
In exactly the same bid, there's only one. It's because if you recall correctly, when we were talking about the ledger object, we only store the highest bid. So we don't. If you have the same bid as the current highest bid, then it doesn't work. Any other guesses? So what we want to be doing is We want to ensure also that the current bidder isn't already the highest bidder. I guess this one is optional. You can take it out if you decide that you can up your bid. I thought it made sense to me, but we want to refund the previous highest bidder because they're no longer the highest bidder. They should get their money back. And then set the bidder of this transaction as the highest bidder and store their bid. So the rest of this amendment is left as an exercise to the viewer, but I'll demo what we have created so far, if we can flip back to my laptop. So I'm going to stop the previous RippleD server, and then I'll flip to the answer folder where I can run the same script here that'll, again, start up RippleD, create the NFT, create the auction, and then submit a bid. So there's the auction that's created, and there's your bid. And now I've still got my Explorer here on the left, and the auction is, where is it? In Ledger Index 6. So if I go to Ledger Index 6 in our Explorer here, we should be able to see that the auction bid was successful. And the bid amount is, in this case, 1 XRP, and it was for this NFT. And now if we go to the metadata, and we scroll down to the auction transaction, you can see that the highest bidder and the highest bid have now been added to our auction. So congrats for your hard work in writing all this code and coming up with what we're doing here. Can we flip back to the slides now? If you would like to do the rest of this amendment, which are the functions of auction finish and auction cancel, feel free to do so. I'd love to see your code, love to see what you can do, and I'm happy to share the version that I wrote if you'd like, so feel free to reach out. If you want to learn more about plugins, here's a link to the repo and the docs. This page will take you to the repo, or this QR code will take you to the repo, but there's also a link to the docs on that page. I'll give you guys a second. And I'll take questions in just a second, but feel free to set up with the mic. And thank you. So if you have any questions or want to reach out about writing the rest of this code or want to see just the final product of the code that I wrote, feel free to reach out via any of these means. And I've got a couple minutes for questions.
Hi. I've got a question about the checks and gas when it comes to reversion. Let's say like the pre-flight checks fail, and then let's say maybe a check when you're actually checking the ledger state, one of those fails. What happens when it comes to gas and reversion and stuff?
That's a great question. So if you have an error in pre-flight, you'll get a TEM code usually, which the error code starts with the letters TEM. The M stands for malformed, I believe. And so if you get one of those errors, then it's free basically. You don't lose anything. If you get a different error code, sometimes it means that it'll stay. It'll possibly be validated later than you expect, but you'll still be charged the fee if it does succeed. And if you get a TEC code, then that means that you lose the fee. You are charged the gas or the transaction fee for that failure because enough processing had to be done to come to that error conclusion that it's just you should be charged it anyways, basically.
Is this a proposal that you plan on submitting, or is it already proposed?
I mean, I'll probably write up an XLS for it, but I can't promise that the C++ code will be written and that it'll be submitted as an amendment. If you'd like to do that, then feel free to go ahead.
What number would you like to give it?
Well, the next one's 71, so unless someone beats me to it, probably that one.
Sounds good. Thank you.
So my question is...
Can you hold the mic closer?
Yeah, sorry. Your plugin package, does it first create the amendment on a local development version of RippleD and enable it at the same time when you run it?
So I enabled it in the config by hand. So it does not. I mean, there's certain settings that you can do to automatically enable amendments, but by default you have to enable it yourself. So if you open up that Docker link and you take a look at the config file that this RippleD is running against, you'll see the amendment name in that config file. But yeah, it was running against the local RippleD node. Plugins aren't really. They're not going to work on mainnet because, you know, if only one node has an amendment and the rest of the network doesn't have an amendment, the rest of the nodes are going to think you're crazy, basically, if you're trying to submit this transaction they've never heard of.
And once you're to the point where you really like what you have and it's successful and you're running and you want to open it up to the world, what's a good method for getting those plugins out there for everybody to see?
So you can, you know, just publish it on GitHub. You can publish an XLS that just does the outline of it. There's plenty of examples for you to look at for reference. And if you really want it to be proposed for mainnet, then either you or someone, or you can hire a C++ developer who can do the conversion. And honestly, for any of the core Ledger developers in this room can tell you that the Python code looks very similar to the C++ code. So it's really not that hard to port it over like that.